All right, today's problem of the day is a plane is flying at 350 meters per second and then accelerates so that it travels 12,000 meters in the next 25 seconds. And we want to know what is the final velocity of the plane. All right, so we can start as always by trying to figure out what the givens are here. What information are we told in the problem?
The plane is flying at 350 meters
Yeah,
per second.
yeah. So what quantity is that? How should I label that?
Would that?
Mhm.
I'm not sure actually. Would that be initial? That would
Yeah.
be the
Sorry. Yeah, that's the initial velocity, right? That's how fast it's going. And we can tell that because it's meters per second, right? Meters per second has to be a velocity. And that's the initial velocity because that's how fast it's going at the start of the problem. Okay, great. What other givens do we have? What other information do we know?
We have acceleration. I think.
Do we have acceleration? It does say it accelerates, but I don't think we have the
No,
value.
delta x.
We have delta x, right? That's right. What's the delta x there?
1,200 meters.
Yeah. Yeah, 12,000, right? Yeah, our delta x is 12,000 meters. That's how far it goes, right? And if it's meters, meters is a distance displacement. That's always going to be our delta x or delta y. Good. One more given in the problem.
And we have the time too.
Yeah, great. We do have the time, right? How long it's flying for. Yeah, 25 seconds. All right, so we've got three givens there. And the unknown, it says pretty explicitly. What are we looking for here?
The final velocity.
Exactly, thanks. The final velocity, VXF. What's that going to be? Okay, so we've got our givens and our unknown. The symbols we've written down are initial velocity, displacement, time, and final velocity. So when we pick which kinematic equation to use, we'll pick the one with those four symbols. And which one is that?
The first one.
Yeah, that's right. It's the first one, right? There's no acceleration, right? There's no AX in the symbols we've written. So that's only the first one doesn't have the AX, right? It's got VXI, delta X, delta T, and VXF. So we'll copy that equation down. And then for step 4, we want to rearrange it, right? We want to make sure our unknown, the final velocity, is all by itself on one side of the equation. It's definitely not all by itself on one side of the equation yet. So when the unknown is inside parentheses here, the first thing I want to do is to make sure the parentheses gets by itself. So what should the first step I take be in rearranging this? Who knows? I want to get this whole piece in parentheses by itself, and it's being multiplied on by the 1/2 and by delta t.
We need to subtract the initial velocity.
You're right that we are going to need to do that, but it's not the time to do that yet, because we can't just subtract it yet because it's still being, the initial velocity is still being multiplied by the 1/2 and the delta t. So we will, in a later step, need to subtract initial velocity.
Oh, so we can divide the 1/2.
Yeah, that's right. We can divide the 1/2, right? Because 1/2 is being multiplied onto the parentheses. And so is the delta t. So we'll divide by the delta t as well, right? So now I can see the 1/2 on this side, the 1/2 cancels out with the 1/2, the delta t cancels out with the delta t, and I'm just left with what's in parentheses. So I have to do the same thing on the other side. So I divide by delta t, and I divide by 1/2, but multiplying by 2 is the same as dividing by 1/2. So what I have now is the initial plus the final velocity equals 2 times displacement over time. And now we can do what Jose said originally, right? The only thing we have added on to what we're looking for is the initial velocity. So now if we subtract that from both sides, then we have initial velocity minus initial velocity, so it cancels out. And we'll do it over there as well. All right, so just to be very clear, I'll rewrite it one more time. We have final velocity is going to be 2 times displacement divided by time, and then minus initial velocity. Questions about how we got that, or did the rearranging for that one? People usually have more trouble when the unknown is inside the parentheses like that. But the thing to remember is just get the parentheses by itself first, and then you can get the unknown that's inside the parentheses by itself. And if you have any more questions about that, you can ask after. Okay. So next we just need to plug our numbers in, right? We're almost done here. 2 times our delta x, which was 12,000 meters, divided by our time, which is 25 seconds. And then we'll need to subtract our initial velocity, which was 350 meters per second. Okay, so if I do 2 times 12,000 divided by 25, that's 960. And then if I subtract the 350 from that, I get 610. So that would mean my final velocity equals 610 meters per second. Meters per second works out, meters over seconds, because that's a velocity and that's what we were looking for. And if we started at 350 and accelerated for a while, going at 610 meters per second for a plane sounds good enough, pretty reasonable.